Hello folks, welcome back. Now, last time we looked at linear searching, and today we're going to go a bit further and do a binary search. Now, linear searching can take a very long time on a very big list. Binary searching is a very cool way of making that go a bit quicker. So, let's see how it works and then we can work out why it's better. So, first things first, this is my list. I've just copied it over. It's copy on the VLE for if you need it. Please note the list is ordered from bottom to top. It must be ordered, otherwise this will not work. Okay? Now, the first thing we need to do is tell the computer what we're looking for. So I want to look for 19, let's say. Keep it simple. And then we need a first and a last variable. So the first is the start of the list. It's not first, it's first. And that is going to be 0. And last is going to be the end of the list. So we'll use the len method. Len mylist, a function. Never mind. Len mylist. So with these bits of information, I can do a very efficient binary search on this list. So what do? Well, firstly, this search needs a loop. We'll call ours a while loop, just for simplicity's sake. While true, that means we'll keep going until I say break. Fair enough. So, there we are. Now it's going to keep repeating anything indented in here. So, the first thing I need to do is work out the middle of my list to start searching from. So, I type mid. And then, I will make this middle number, this mid number, must be an integer. It must be a whole number. So I'm going to cast the answer here as an integer. And then I want the midway point of the list, the center of the list. So that's going to be first plus last divided by 2. So we just open up and 2 brackets here. So first plus last. So that's telling me how long the list is. We are going to change first a few times probably, so we have to do that. And then I divide it by 2. There we are, nice and easy. So middle is now first plus last divided by 2. And it's a whole number. Why? Well, we're about to see. So firstly, for a binary search, we do say, is the number in the center more or less than 19? So, firstly, we say if the number in the middle, so if my list middle is equal to the number, so if we've got the right number, we've got halfway point, boom, oh, that's the number we're looking for. Perfect. Brilliant, fantastic, sweet. We just say print, and we say we found it. So found it at, and then put the position it's at in the list. So if it's there, perfect. But let's face it, out of 8 numbers, odds are it's not going to be there. So we're going to have to move on. But if we found it, we can stop searching, we can stop looping. So we're going to type break to break out of a loop. Okay? So now we need to search somewhere else. Now, as we saw earlier in my demonstration video, if the number is bigger than the halfway point, then it must be in this half here, so we can ignore all of these. And if the number is less than 15, it must be in this half here, so we can ignore all of these numbers over here. So what we have to do is alter first and last to make that happen. So firstly I need to do an elif. Else if, or elif, num is less than my list mid. So if it's less than the middle of my list, what am I going to do? Well, the answer is the last number, this number here, I'm going to change to be the middle of the list minus 1, because I've already checked the middle of the list. So all I do is I just type last, and then I type in mid -1. Okay, so that will suddenly search down to the change the center of the list, so we're only searching in the bottom half. But what happens if it's the other way around? Elif num is greater than my list mid. Well, in that case, we need to do exactly the opposite. We need to say you need to spell right, which would help, wouldn't it? It's a bit early, what can I say? So I'm going to say first equals mid plus 1. So it will then search in this space in this area. Okay, so let's just see if this works. So hang on to your hats and press play. Found it at 6. So 0, 1, 2, 3, 4, 5, 6. Spot on. Let's try a different number. Let's say 9, which should be appearing at 0, 1, 2. If I run it, found it at 2. So the computer is searching each half of the list and reducing it again and again and again until eventually it can find the number. Don't forget, this only works on sorted lists, but this list is sitting on the VLE for you to play with right now. So, thank you for watching.